very excited. Everyone see some pretty good demos today?
Yeah.
Awesome. Good. Well, that is just the beginning. I'm very proud to present our keynote speaker. He really needs no introduction, but I'm going to do it anyway. He is the founder of Second Life and currently doing something called high fidelity, which I think you will find very interesting. Let's welcome to the stage Philip Rosedale.
Thank you. Thanks very much. My co-founder Ryan there just looked over at me and said, "It's not like we're trying to do a complicated demo or anything. We're going to give you hopefully as complicated a demo as you can possibly stand, or maybe as we can possibly stand." So thank you very much for having me. It's a delight. As someone over the years who's spent so much time evangelizing virtual reality, it's wonderful to get a chance to sit here and talk to the gang, I guess, somebody that, for the most part, probably don't have to evangelize very much of these things at all to. So it's wonderful. You know, in thinking about the title I've given, obviously more and more talks lately about virtual reality and what it all means. And I love the revenge of virtual reality, because virtual reality seems like this sort of monster that is always almost upon us with its implications and excitement, but it never quite sees the light of day. And it's been that way. We've got a 1987 Scientific American at the office with one of the gloves on the front. The title says, "The next 10 years, computing will be revolutionized by virtual reality." So I love this idea, but I do think, and of course I have to laugh saying this, I do think this time it really is coming. And so what I want to do today is give you maybe our own perspective and high fidelity Second Life on what virtual reality really is, why it is coming this time, and then ultimately what that is all going to mean. So, you know, the first thought I had was this one. I keep hearing this virtual reality. We've all been saying it for years. You ever look up the definitions of it? They're not very good. If you look up the definitions, it says stuff about computers. Inevitably, it says a computer, something about like a head-mounted display or gloves or simulation. The word simulation is encountered a lot. I don't think that really addresses the meaning of virtual reality. And in thinking about it in our own work like this, do you have to have a head-mounted display or a glove to do virtual reality? Does it have to be computer-generated? I've been thinking about that a lot. And I think this definition is one that fits more to the challenges we now face and the opportunities that are in front of us with all that's happening. I think virtual reality really is precisely this, which is some sort of a sense experience where things actually happen the way we think they should. So if I turn my head to one side, the rest of the room shows up. And that expectation has been with me all my life, and I think what we mean when we say virtual reality is at a lot of different levels of complexity. What it means is stuff happening the way we expect it to, and the way we've always experienced it before. So I actually think this definition is pretty good. In fact, if you've read the book on intelligence, which is a great book that has really influenced a lot of modern thinking about artificial intelligence, its author, Jeff Hawkins, gives an example. Basically, the book explains that a lot of what we do in our brain, and we're now understanding this more and more in the last few years, a lot of what we do with our brains is guess at what's going to happen in the next few seconds, build a model about what we think is going to happen when we do the next thing we're doing, and then see how well the world, the sense experience we receive fits that model, how closely. He gives this wonderful example, which does make me think of VR in a way. He talks about, imagine somebody going to your house when you're coming home at the end of the day and you're in your own mind and reading your emails and walking up to your front door. But just before you get there, we've snuck in like little ants and we've basically like greased your front door on the inside. We sort of changed the workings of the door a little bit to make it smoother than the squeaky door you're used to. And he talks about how in a second, when we put our key in the lock and go to turn that knob, you can all imagine it, right? We'd all suddenly alert, like, what's going on? You know, is somebody broken into my house? Something's wrong. And that's because the sense experience of turning that doorknob is one that you've had 1,000 times before. And if you change even the tiniest piece of it, you suddenly know something's wrong. And so I think that something's wrong, or the lack of something being wrong, is a huge part of this whole promise of VR. So I think computer simulations are VR, but I'd say that I guess our own dreams are an even better example in which things really happen in a manner similar to what we expect because they're in fact taken from our past experiences. But this is also true at a bigger level. When I go into a crowded street, I expect there to be people. And when I look at the people, I expect them to make eye contact with me. And when I try to make a change to the world around me, I expect that change to happen. These are all expectations we have where we want things to work like we remember them or like we expect them to be. So, next, let me tell you about my own unique kind of love of virtual reality and why I really got passionate about it and why I devoted my whole life to working on it. So when I was a kid, I really wanted to be an astronaut. I mean, I can remember that. I was a tinkerer and a builder, and I loved the idea of going into space. But at the same time, I was also a young computer programmer. And as I started programming computers, one of the first things I worked with, and I bet lots of people in here, who knows what we're looking at? That's pretty good. That's the faithful. This is, of course, a big drawn-back version of the Game of Life, Conway's Game of Life, and this remarkable video, which I found on YouTube, shows kind of how big things can get as you scale up the amount of processing you're doing with the Game of Life. You can actually make organisms that can reproduce themselves and machines and everything. So as a kid, I was programming, doing these cellular automata, and I was fascinated by the possibility that I saw with computers, which was that somehow you could basically rebuild everything, build the world all over again inside the computer, and that from these very basic, very simple, silly rules, you could see amazing things happen built on top of them. You could see these systems become bigger and more complex. As I went to college, I studied physics. I became increasingly convinced the more I learned about physics that there really wasn't anything that seemed to be going on in the physical, real world that wasn't something that couldn't in some way be created inside the computer. It seemed as if this idea of little parts coming together to form something amazing seems to happen everywhere, and nowhere is there a better example than flocking birds. Again, many of you here have probably worked on this problem, and you know that birds flock in this beautiful way that they do, not because of the innate intelligence of birds, but because they're obeying a couple of very, very simple rules that are so simple to program on a computer that they were first demonstrated in the 1980s by a guy named Craig Reynolds, and they were an amazing sort of proof that you could make flocks of birds and many other complex things inside the computer. Now, many of you have probably never seen this, or you may have, but when you scale up the number of birds, really crazy stuff happens. You go from 20 or 30 birds to a few thousand birds, and you start to see emergent patterns, things that you could never have possibly predicted coming from these motions. You can't watch a few birds and guess what these birds are going to do. And so as we started doing our initial development at High Fidelity, we were asking questions like, and this is also how I felt from the beginning of Second Life, what would it be like if there could be, say, 200,000 birds flying around near each other in a computer? Now, you can't have that number of birds in the real world because there's not enough food anywhere in the real world for these birds to eat. But you could simulate that inside a computer. And as I started to really think about this, I started to realize that if you could reproduce physics, if you could reproduce everything inside the computer, if we can build persistent networks of machines connected together to do this, we may be able to create a world so complex there that it begins to rival or replace pieces of the real world. And going all the way back to being that kid dreaming about going into space, what I realized was that maybe it's the case, as this all happens, as we connect all these computers together, as we make them increasingly capable of doing amazing things inside them, maybe it's going to be the case that the thing we're all kind of excited about when we think about space isn't something we're going to find out there. It's difficult to go into space. It will still be in our lifetimes. but instead something that we'll produce inside computers, that we will create the alien landscapes or maybe even life forms that we dream about being out there in space, but that they'll be inside the machines. And so that was what really moved me as a young entrepreneur, and is what has continued to move me in all my work on this stuff. And Second Life today is the greatest, I think, again, example of virtual reality we have yet in the world. It's an enormous space spanning some 40,000 server nodes, and it's a space in which people have, to date, bought and sold things, for example, from each other to the tune of more than $3 billion US. And so the very first stages of this movement have already been fascinating and exciting. But next, what I want to talk about is why we're not there now. This graph, and you can see virtual worlds, I don't have a laser pointer, but you can see virtual worlds as that little blue dot right at the bottom of the trough. This is the Gartner hype cycle. And what they've done up here, you should look this picture up because it's gorgeous, and some of the things you've worked on are probably up there. They've put little dots on where on the hype cycle of initial expectations giving way to disillusionment and frustration, and then ultimately growth into a real functional product. You can see that virtual worlds, not virtual reality, I suppose, virtual worlds are right down at the bottom of the trough and beginning to climb the other side. So I guess what's exciting is, Gartner's telling us that the next 5 or 10 years at least will be big ones for VR, and it says 5 to 10 years is sort of how far we are from mainstream adoption in that image. I love that summary of this. So why aren't we there right now? What is it that is keeping us, and hopefully, what is it that's different now that we're all excited about? Well, look at this video. This again is my co-founder Ryan. What's he doing? Well, he's trying hands on the mouse and the keyboard. He's having to use the keyboard like a chord. He's having to play some buttons on the keyboard while he moves that mouse. And he has to do that to move around and manipulate this simple object. Well, that's incredibly difficult. My personal opinion is that's the biggest and one of the only reasons why we don't have 1 billion people using virtual worlds today. We only have 1 million or so. A lot, but still 1 million. Is because of the difficulty of that movement. But now take a look at what's happened. We're all talking about the Oculus this morning, and the Oculus is absolutely fantastic. Once you put it on, you will suddenly be immersed in a visual world that you've never felt before. But there's a lot more happening. As Palmer said earlier, the Oculus itself is fueled by this revolution in mobile devices and miniaturization and sensors that affects a whole range of different products. And you've got a bunch of them. Actually, I think everything else is out there aplenty in the exhibit hall today. So basically, when I think about virtual reality and this coming revolution, I don't think as much about visual immersion. I guess as a dreamer, I kind of always assume, I'm always assuming it's there or it's going to be there. Now it is, thanks to Oculus. But what's more important is what is fixing what Ryan was trying to do with his hands there. And there's multiple approaches at how we can do that. And that 3D camera up in the end, well, I'm going to show you that work. That actually allows us to, see a person moving and see their facial expressions. All of these things are pieces of hardware that are out there. So what are we going to do with that? Well, you've heard a lot of talk about latency and about how intolerant our eyes are of latency, and that's, again, one of the things the Oculus has so elegantly attacked and solved. But there's an additional kind of latency. These virtual worlds, virtual reality is going to be real to a large extent because, as we expect, we will find other people there. The face-to-face experience of talking to somebody, which is what we've been working on at High Fidelity, is absolutely riveting if it can be done right, if it can be enabled inside virtual reality, inside of virtual worlds. And latency is a big thing there, too. In 2003, the ITU made this study that we've used as which is why we tend to use Skype, for one of the reasons. And 100 milliseconds is what we're shooting for with high fidelity, and 100 milliseconds is what can actually be achieved in virtual worlds today. We're doing it now. I'm going to show it to you in a couple minutes. This is kind of fun. It's hard to put you on either side of the demo, just like with the Oculus. I really feel for Oculus because obviously it's really hard to get up on stage as Palmer and put the thing on and say, oh my God, you guys, it's incredible. You can't believe it. You can't do that for the audience. It's super hard. You can't show latency either, but let me show you this. It's kind of cool. The first clip here is a Star Wars clip where we've put in latency to get you to kind of feel cognitively what the delay is like. This is at 100 milliseconds, which is our target, and then the second one is basically what your cell phone feels like. So see if you notice the difference here.
We gotta do something. What are you talking about? The droid belonged to her. She's the one in the back. We gotta help her.
Now look, don't give me funny ideas. The old man wants us to wait right here.
If he didn't know she was here, just went over back into the detention.
That's what we're shooting for. You can see those little breaks between the words. That's what we put in so you can feel that. And this is a cell phone, just a little bit more.
We gotta do something. What are you talking about? The droid belonged to her. She's the one in the back. We gotta help her.
Now look, don't give me funny ideas. The old man wants us to wait right here.
If he didn't know she was here, just went over back into the detention block.
So isn't that interesting, right? The second one isn't just a little bit worse, it's a lot worse. Something starts to bother you. Do you think you could watch the whole movie that way? You couldn't. You wouldn't like it. And the first one is right at the edge of perceptibility. Of course you can see we're stopping the image. Actually, we're stopping it in these cases for twice the transit time, which is what you feel when you're talking to somebody. But 100 milliseconds is a magic place. And I'll tell you another good thing about 100 milliseconds that makes the future of virtual reality really bright and shiny is that we're on such a small planet. It turns out that the speed of light tells us that it takes about 100 milliseconds for internet packets to get to Singapore. You can try that today. It wasn't true a few years ago. Our routers are rapidly approaching the speed of light in their ability to move packets around on the internet. And what this means is that halfway around the Earth is currently about 100 milliseconds. So we are pretty much in range of putting all of us, all 7 billion of us, in a virtual space together and have things feel like this sort of 100 millisecond magic point. So that's pretty remarkable. We're lucky to live on such a small planet and at a time where we've finally gotten our routers fast enough to do this stuff. Now the next question is the server devices, right? And when I say 100 milliseconds, it's from a device to a device. I don't just mean from you to a server. That brings us to something that may be even more important, because there are less than 1 million server machines out there. And Second Life alone takes up, as I said, some 40,000 nodes. I'm not sure what the FA team are here as well from Second Life. I'm not sure how many physical machines we have there, but it's thousands of machines. But to build a really enormous virtual world, we need to actually get a lot more machines involved, because virtual worlds are highly complex. They're simulated. They've got physical objects in them. They've got you in them. There's a lot of server demand. And I personally believe that one of the revolutions we're going to have here is we're going to realize we don't even have enough machine power. We've got to actually get to more machines. And yet, and so the good news is that that sort of 100 milliseconds happens from device to device nowadays. It happens from just about any machine to any machine. And the answer, if you look just at PCs, is that we can potentially go from 600,000 or so servers to 600 million broadband connected PC devices, which is what we have today. So we have 3 orders of magnitude. We have 1,000 times more computing available in our own machines than we have in the cloud computing servers that we have in the world today. And so where is this all going? Imagining that idea of using a ton of machines. Well, obviously Moore's law is the fundamental driver here. It's driving all our technology. It's even driving our bandwidth. It takes a little longer to do it, but everything is being driven by that. So where is that all going? Well, one thing that means is that there's a gap. Well, let me just show you this next slide. There's a gap that one thing we can say about where virtual reality is going is there's only a few years at any point along that Moore's law curve that lie between seeing what we see on our computer screens and our computer games today, our interactive live environments, and what we see in the movies. That gap is probably 5 or 7 years. And if you take a look at these 2 movie clips, the one thing that's different about them was, you guys probably know this, we've got a lot of people here who probably know exactly what we're looking at, but the one on the left is a $100 million motion picture Final Fantasy made in 2000, who knows when Final Fantasy, I think it was 2001 or something. And then the one on the right is live. It's now a live rendering. And they're pretty comparable. And those were separated from each other by a span of some 10 years. So what this means is that the virtual worlds of the future are going to look like Pandora from Avatar. They're going to look like this. And once we can build things in those worlds, I would assert to you that even those people here who are passionate about this stuff have no idea what is coming. Because we are about to be able to build worlds that, from a sensory experience perspective, feel like that. We're going to be arguing over the price of real estate in the forests of Pandora, which is a really shocking thought. And if you look at even the best things that have been made in Second Life today, I mean, they're fantastic, but this is just mind-boggling, and this is what we're going to be grappling with in so many different ways here in just a couple of years. And where does this all ultimately go? Here's a crazy thought. I think, again, Homer's talking about this crazy talk. Want to talk real crazy talk, you can say, well, how much virtual reality can we actually build? How fast are our computers capable of going? Well, if they double every couple of years, and they do, what you can do is you can do this math that says 30 or 40 years from now, how fast can a MacBook Pro go? And the answer is this. It turns out there's a bit of a quantum physics limit to how fast we can compute with a piece of aluminum or anything else made out of atoms. And that number is a staggeringly enormous number, 10 to the 50th instructions per second. Let me give you an idea how much simulation that is. It's enough simulation to take every atom in the body of every person now living on Earth, plus a good 100 feet of topsoil from Earth itself, and simulate all that, and have enough time to do 1 trillion calculations per second per atom in all our bodies. And that's the limit capability of what one laptop computer can simulate, one whole world the size of ours, to that level of complexity. And when you scale that all the way up and imagine the whole universe itself as a big, massive computer, you get to a number that is just so staggeringly large it doesn't matter, which always brings me back to that wonderful Richard Feynman quote, there's plenty of room at the bottom. Which means there's plenty of room for virtual reality. There's a lot of room for computing, and the more we get access to it, the more we create these sensory experiences that are like this one, the stranger and more unbelievable things are going to be. I don't begin to believe that we even understand what's going on. So with that, let me shift over and let us actually show you a little bit of what we're doing at High Fidelity and give you a few more fun things to think about. Hang on one second here. I've just got to